Hello, everyone, and welcome to the talk of me and Frédéric, the talk called Making Use of snapshot.d.o for Fun and Profit, where we will talk about all the stuff we did in the recent years in connection with the snapshot service. My name is Johannes Schauer Marin Rodrigues, or short Josh. I am the upstream author of debsnap, sbuild, and those are three, and the service maintainer of bootstrap.debian.net, binary controller.debian.net, and now also a new service that I will introduce in this talk called metasnap.debian.net.
Hello, my name is Frédéric Pierret. So for those who don't know me, I'm mostly doing some research and development about modeling of mathematical dynamical system, but also how we can build tools for operating system and packages. So you can reach me on GitHub under the nickname of Epitre, but also on my email address. So as the email address suggests, I'm part of the Kubes project in 3 years, for which most of this talk is the motivation.
I want to show a short timeline of what happened in the past years. I started working with the snapshot service in 2014 when I was still doing more things for the reproducible builds efforts. And I wrote a small script called buildinfo to snapshot, which basically took a buildinfo file and figured out which snapshot, Debian snapshot timestamps one needed to build a change root that consisted of all the packages referenced by that buildinfo file. That script was in the following year extended to the srebuild script. It was named like that because it was focusing on working with sbuild. And that was then in the following year renamed into debrebuild, as the script was then more general, not only supporting sbuild, but also having backends for pbuilder or just the package build package. In 2020, I wrote the debisect tool, which uses snapshot.debian.org to bisect Debian to figure out bugs when they were introduced and which package introduced them. I finally started the metasnap service, which was needed to work around limitations of the snapshot.debian.org service. And Frédéric started his own debrebuild script written in Python and not in Perl like mine. And this year in 2021, I started the debootsnap script, which is not yet in dev scripts like the debisect tool is. And Frédéric wrote the package rebuilder and started his own snapshot mirror. We start to talk with the current situation, where we stand, what we actually want to have, the problems we're facing, and spend then most time of the talk about the solutions that we implemented. The current situation is that we have an amazing service as snapshot.debian.org collects all data, all packages files, all release files of all of Debian starting 2005. That includes not only backports, debug packages, Debian ports, security packages, and Debian volatile. It is, as of 2019, 90 terabytes of data in more than 35 million files and all architectures we ever had, including all the ports architectures. And right now, the main interface to the data that is stored by the snapshot service is the debsnap tool from DevScripts, which unfortunately does not do GPG verification. It uses the snapshot API to download arbitrary files. And it is good enough for that, but for anything more, we are running into problems. What we actually want to have is set GPG verification, which the debsnap tool does not do. We want to be able to reproduce binary packages using buildinfo files. That's what the debrebuild tool was meant to do. We want to be able to bisect Debian, to be able to track down bugs to specific packages. And we want to create Debian change roots with particular package versions to also reproduce bugs that people find. The problems and why we haven't had all of that for a long time already is that the snapshot.debian.org service does not associate the files it offers, the raw package files, the binary package files, to the release files, to the assigned release files that reference them through the packages files. And because of that, we can download all the files, but we cannot be sure that they actually verify with the signatures that we know. And the API also offers a first seen attribute, which is useful in the sense that we get the snapshot timestamp where a binary package was first seen anywhere in Debian as a file, but that attribute has different problems that we will also talk about later. And last but not least, we come to the network problems, which pained me and Frédéric a lot during the past years. For example, when we just want to build, we want to debootstrap, here using debsnap, a Debian change root that includes LibreOffice. I used debsnap and not debootstrap because debsnap uses apt, so we mimic what would happen when any user would use and interface the snapshot.debian.org service using apt. If we try that, then we run into problems that look similar to this one. We quickly get a could not connect and connection refused and cannot initiate connection from apt. And if one tries this a lot more, and then we get even more funny errors, error reading from server, hash sum mismatch, and so on and so forth, all of which makes the snapshot.debian.org service not useful in situations where we want reliability. When we run it as a normal user, we can restart the program we ran, but we cannot use it as a service, for example. There are several solutions to these problems. One of them is being worked on by Julien Christo, and he suspects the issue might be the varnish cache. There are several bugs open in the snapshot service, and maybe we get the issue solved that way. Solution number 2 is to run apt with some options that limit download speed, but this is not a 100% solution. If apt downloads a lot of very tiny packages, we again get the network disconnects, and somehow it seems that the IP that we download from will be blocked and cannot make any connects for a small amount of time, and thus we will fail again with apt. Solution number 3 is to have a bit more clever proxy between apt and snapshot.debian.org. That proxy has to be able to do several things. It needs to download with no more than 1000 kilobytes per second. It has to time out connections after some seconds of inactivity, because snapshot.debian.org sometimes just stops a connection, doesn't drop it completely, but just doesn't send any data anymore, stalls forever. We do not need to download more than 2000 files per hour. That seems to be a weird limit, but I figured out that if one limits the rate at which we download individual files, then it works rather stable over a long period of time. And we need to retry downloading if either the files we get had 0 size, that also randomly happens, we get interrupted partial downloads, we get an A couldn't connect from curl, or we have the set inactivity, or we get any HTTP error that is not 200, 206, or 404. Most likely snapshot.debian.org will give us a HTTP 500 error for some reason, and this will also then not happen anymore when we try again. Trying again, we have to use a back off time. It seems we somehow, again, trial and error, we need to back off by 4 to the power of number of retry seconds. I tried 2 to the power of retry seconds, which didn't work. So having a proxy with these settings works, but is clunky and shouldn't be necessary to interface with the service. Solution number 4 is what Frédéric is doing. He is running his own mirror of snapshot.debian.org that does not have the restrictions that I just talked about and will be introduced later in this talk. Solution number 5 is to download slowly, for example, using the proxy I talked about earlier, but use the download data to build a local package cache. And that is, for example, what the debisect tool is doing. The debisect tool, just shortly, is a tool that works like git bisect, but for Debian. It proxies apt downloads from snapshot.d.o in the way that I explained earlier to not hit the rate limits, and then caches packages locally, as when we bisect from two different timestamps and get closer and closer to the actual timestamp. Lots of packages repeat, so it makes lots of sense to cache the requests. And the script that it runs, just like git bisect can run script, is either run just plainly, just being passed the current bisecting timestamp, or it is automatically run in the change root, or it is run inside QEMU. And that way we can use debisect to look into all kinds of packaging problems. For example, I used debisect to reproduce a Debian bug, and here you can see the invocation. We tell debisect that we need one package to be installed. Botch was the one that had an error here, and we run debisect between these two timestamps. And our script is the one in this line. We just change root call the script that was failing after a certain timestamp, and the script will figure out that what was happening was that at some point Python 3 minimal upgraded, and that triggered the problem. Currently, debisect cannot skip timestamps. This is because snapshot.d.o does not export a machine-readable list of timestamps. So while bisecting, we do not know what timestamp we end up with. And we cannot yet restrict the timestamps we do test to those where a given package set changed. But this is solved by the metasnap.debian.net service that I'll introduce later. I also wanted to talk about the first scene attribute that I mentioned earlier. The first scene attribute is an attribute of the snapshot.debian.org API, and it lists the snapshot timestamp where a given file stored by snapshot.debian.org was first seen, mostly a binary package when it appears in the pool directory. The problems with the first scene attribute were known since 2014, but it was not until last year that I figured out how to work around this. The problem is that a package can be in the pool directory and thus have the first seen from that timestamp onward, but not be referenced by a packages file. So while one might naively think that the first seen timestamp tells us when in Debian Unstable we can expect a package to be there, that is not always the case. Some packages, for some reason that I do not know, only pop up later in the respective release or packages file, and some packages are even in the pool directory and never appear in a packages file. And the other problem is that while it records when the package was first seen, it does not record when the package was last seen. So we again have not a good way to figure out, given, let's say, 100 packages, which minimal set of timestamps we need to retrieve that number of packages. And it also does not account for holes in the interval. It does happen, for example, that a package disappears for some timestamps and then reappears on snapshot.debian.org some timestamps later. And all of that is something that a first seen attribute cannot usefully solve. So I introduced the metasnap.debian.net service. The metasnap.debian.net service is a public web service with a machine-readable API. And basically what it does is that given a package version architecture tuple, or many packages that have a version architecture, it returns which Debian suites had that package for which range of snapshot timestamps. And for example, one can use that service to just upload a buildinfo file, and one will get back the information which Debian suite at what timestamp one needs to retrieve all the packages referenced by that buildinfo file. That service is right now used by 3 tools of mine: the debisect tool that I mentioned earlier, the debootsnap tool that I will mention later, and debrebuild. And currently, the service stores all archives and all timestamps and all architectures from snapshot.debian.org. And unfortunately, the information it stores is 12 hours old. So the most recent timestamps cannot be stored because of another feature missing from snapshot.d.o, where we can not figure out whether a timestamp listed on the website is actually already fully mirrored or not. So the service only contains snapshots that are more than 12 hours old to not try and attempt to store partially mirrored snapshots. I come to the debootsnap tool. The debootsnap tool is a tool I wrote because I was in a situation where I had an upgrade bug. I upgraded the system, and after upgrading it didn't boot anymore. And I did not know why that happened. The system was a partially upgraded Debian testing system, so all package versions were mixed together. And I wanted to figure out why did that happen. So from the apt logs, I figured out how the system looked before I upgraded, and I was surprised to find that right now we do not have a tool in the archive that allows me to recreate a system given a list of precise package versions. So I wrote the debootsnap tool, which is currently a work in progress merge request to dev scripts, and it can be used in the way that one can see here. So one can just pipe, for example, the dpackage query output into it, to the debootsnap tool, and it creates a change root with just these versions. Or one can give it a buildinfo file and again get a change root tarball that contains just the packages referenced by the buildinfo file. The debootsnap tool uses metasnap to compute a minimal set of snapshot timestamps, and it uses debsnap to create the change root instead of debootstrap, because it oftentimes happens that we cannot download all the binary packages from the same snapshot timestamp, but need multiple timestamps, and then we need support for multiple mirrors, and debootstrap cannot do that, so we use debsnap. The second reason being that when we want to create a change root that does not contain apt, and this is the case when we, for example, get a buildinfo file. Buildinfo files do not contain apt as a package. Then we need to create a change root containing all the packages referenced in the buildinfo file, but without apt being installed itself. And debsnap can do it, debootstrap cannot. And this allows reproducing bugs. So in the future, when we get debootsnap actually in dev scripts, we will be able to tell users that come to us, hey, give us the list of packages you've installed, and we can perfectly reproduce your bugs because now we know how your system looks like. The debrebuild tool is one that I, as initially in the timeline I showed, rewrote a lot. Currently, I'm on the third rewrite. Right now, the third rewrite ditches about 600 lines of code because now we have the debsnap tool, we have the debootsnap service, and we have the debootsnap tool, hopefully soon. And with that, we can fix all the bugs that the debrebuild script had in the past. And the debrebuild script will rebuild a source package and change root with all the package versions from a buildinfo file. And while in the past used to use the first seen attribute and the base files upgrade heuristic, which were all horribly wrong and all horribly bad, it is now a thin wrapper around debootsnap and can create just the change root we want and then run the package build inside of it.
So we are motivated by reproducible build goals and mainly by how we can at first provide for CubeSWISE reproducible packages for our Debian template. So I'm involved in reproducible build since 2018, if I remember correctly, but mainly I start doing active stuff since last year. So when I start doing so, I've tried to see how Debian is doing, what are available tools. So I found after some discussion with the community that there exists debrebuild in dev scripts. So looking at that, what is debrebuild? It takes buildinfo generated from packages and it attempts to reproduce it. But One of the limitations of this original tool is that for CubesOS we need to add one extra repository, and also that we want to generate some attestation that the package is reproducible. So here we wanted to use what is called in toto metadata. So according to this, notably to these two, like in the original debrebuild tool, we decided to simply rewrite a tool in Python first because it was simple for us, notably in what we have in mind that we'll talk about after. So this is, so as I said, a similar tool that debrebuild is written in Python. It can be used as a standalone shell tool, of course, but also it can be used as a Python client to be imported in other code. So as I said just before, this was one of the motivations to rewrite our own tool. So we can find this tool on my GitHub repository here. Next, having this reproducible software, the question was how we can finally rebuild all the CubesOS packages, and also how we can finally rebuild all Debian packages, and this without manually trigger all the time the rebuild. So after discussing with the possible community, I was imposing myself some constraints, notably for the sake of simplicity, that I wanted first a standalone software that would be doing everything, in the sense that I wanted an orchestrator and also workers that will rebuild packages on the same machine. So I decided to write a tool that I call Package Rebuilder, which is standalone, of course. Its global architecture is pretty simple. You have an orchestrator. Behind that, there is a technology called Celery, which is a famous task orchestrator in Python. It uses for its internal use only mostly a broker and a backend. It is responsible to orchestrate and handle all the tasks and the result. And there is the three and more services, because we have, in our case, a getter services, an uploader services, and of course rebuilders services, meaning that we have several workers that will be in charge to rebuild stuff. So it runs under Docker. You have a Docker compose which will be in charge to run all of these services and manage the whole. So that was notably one of the reasons to doing so, having something simple. So it works. The getter services will monitor the queues, the Debian repositories, and it will add some tasks to the rebuilder queue. Here I talk about Fedora 2. In fact, when I start doing this, I was not only doing this for cubes, the Debian part of cubes, but also the Fedora part of cubes. So I start doing some work for the Fedora community too. So the software, the package of the software is written in the more general way, with the most generic workflow for rebuilding stuff that allows us to also trigger soon Fedora rebuild packages. So having packages in queue, all the rebuilder will of course try to rebuild using debrebuild, our debrebuild tool in Python, and also RPM reproduce, which is a similar tool of debrebuild, but this time for RPM. Having rebuilt these packages, it will generate artifacts. Here by artifact we mean mostly the in toto metadata, so the attestation that package is or not reproducible, but also some logs and statistics of the whole rebuilding orchestrator. After that, it finally serves a repository for the APT transport of in toto, and its equivalent of DNF for the DNF plugin. So briefly, a few words about about this transport. This transport will after setup and configuration that for example we'll have all the repository that our rebuilder setup will serve. You will say when you will try to download to install a package locally, IPG will request this third repository to ask if he knows this package I want to install and if he knows that there is or not attestation about its reproducibility. If it has and it is reproducible, it will say, oh, it's fine, so the package will be installed. If it's not, it will simply stop the IPT transaction. So at this time, it will be very useful for us to know if a package or not is reproducible by simply trying to install it locally. So after doing that, so meaning having a whole machinery orchestrating the whole rebuild of Debian and other distribution running like CubeOS packages, we faced a major issue that if you have say 20 rebuilder trying to rebuild buildinfo file at the same time, behind the debrebuild software there is a use of snapshot Debian, meaning that for a set of build dependencies we need to have the exact version, architecture, etc. of the packages. So for that we use Debian snapshot, but there is this issue by doing too much request on it. Those are known. There is some throttling limits. So we were finally quickly blocked by trying to rebuild a lot of packages at the same time. So that's why we finally decided to run our own instance. By that I mean we simply rewrite from scratch the full independent snapshot services, and notably with the goals to be scalable in terms of handling a lot of requests and to serve a lot of repositories at the same time without limits. So we start a project that I call Debian Snapshot, which is mostly the same name that the original Debian Snapshot will be. So with respect to this original snapshot, we use, for the sake of simplicity first and compatibility, the same timestamp value, meaning that each time the original snapshot service creates timestamps value to then register what's inside the current FTP master or Debian master repositories. We use the same value and we use also the same data locally. So we mirrored all this data from the original snapshot, notably from 2017 and today for Unstable, Buster, and GUI Suite, but also for all source and AMD 64 architecture. We plan in the future to add more, but currently we focus on usability and stability. So as I said, up to past data that hopefully snapshot still have since I think it was 2005. It runs on its own, and you can reach the snapshot, the timestamp repository. So it's a Debian repository at several dates on this URL. But also we developed our own API, notably to address several goals for rebuilder software to help rebuilder software to find dependency and information. So same as the original snapshot, there is an API exposed here. So let me show you some examples that you can have with these new services. One of the issues addressed, it was that there was not machine-readable format for getting all the timestamp values available on the service. So that was mostly one of the first things I did. So it's a simple request that if you request the timestamp timestamp resource, you want the Debian archive timestamps available in the service. You get JSON result in JSON with all the timestamp value available. So here on this slide, it's not up to date because you will have the latest timestamps of today. But also, one important thing for rebuilder software is that you query info on source of a given package. So here, as an example, with Python, there is a client with this version. So you request here the service, and you get some information about its hash. Notably here, in contrary to original snapshot service, we use SHA-256 sum to store every file that we have in locally and in database. And also similar information that you have for file info. Up to that, we added the support for a given file in which, so you have standard information, name, path size, but so original snapshot provide archive name, but also we add in which suite, in which component name the file has been seen, but also every timestamp ranges it has been seen too. So by timestamp ranges, we mean that, for example, the original timestamp, original Debian service will store only the first seen value, which will have been this one, but but it will have to store the next values. First, I think it was for space consideration of database, but so we try to simply create range. So range by range we mean it represents like an interval, the beginning and the end of every timestamp in between. So here you have, for example, four timestamp range that's saying that the file here, TSC file of this package, is present in all timestamp in between these two values, also in these two values, etc. As you can see, it's not continuous because, as Josh saw a while ago, that mostly in the past there was a case that a file from one timestamp to another, maybe multiple, will not be here. So I don't have the reason for that, but it has been observed. So we keep this information to be able to know exactly where to find the package. So this is also available for binary packages, of course, but notably one of the most important information that we need for rebuild a package is that we need to limit the number of repositories we are going to add, because, for example, if you have 40 dependencies for rebuilding a package, you will not add 40 repositories from the snapshot service. First, as I said, there is some throttle limit. So imagine if you do that for every package you want to rebuild, you will simply destroy the snapshot infrastructure. But also, up to the number of dependencies, so the number of timestamps you will need, you do as much as the same number of requests on the API to getting information. That is the one who allow you to know which timestamp the package has been seen. So doing so, it's not optimal because multiple files can be in the same timestamps, but they will have not be first seen at the same time. So the idea, notably for the original MetaSnap services, was to try to compute, knowing the number of package dependency, how we can find the minimal set of timestamps that we need to cover every dependency in terms of name and version we need. And so this is why I call it a la MetaSnap. So if you post, for example, this buildinfo file on the API, as the same as the MetaSnap, it will compute you here for the Buster suite, for example. You need just one timestamp to rebuild this packaging, and not as much as timestamp as the number of dependencies. So yes, the feature is pretty new, is in testing, so it's still a lot of work to do. So thank you for I'm finished for my part. If you have any question, don't hesitate to reach me on GitHub or also my email address. I will be very pleased to help, and also I welcome every contribution to all of these tools. Thank you.
Okay, so thanks for the talk. Now we can go to questions. As you see, the other pad is quite filled. So let's go to question 1. So let's see, by Sigu, the Python code behind snapshot.d.o is designed to have multiple storage backends. However, it currently only supports a file system as a backend. If it was able to support OpenStack Swift or S3, probably it'd be easy for sponsors to host a mirror. It would also make it more reliable and easy to administer. Have you thought about adding such an OpenStack Swift support? If not, maybe could have an outreachy sum of code project for it next year.
Well, I think it's a question for me. No, we have not thought about this because it's pretty new. In fact, we wanted something working for quickly. So it was something simple, just a local file system. But I mean, such improvement or such handling of backend like it was like it's requested deserves to be discussed. So I would say I will invite every people who want to work on that or to think about how we can do that to go discuss with us. So yes, why not? I mean, it's fine if it's allowed to scale data. I would say yes. Why not?
Okay, there was a second part of the question, which is about Infomaniac offering they could sponsor the storage, but you could read that. But let's go to the next question. Are the snapshots on snapshot.d.o deduplicated across files, and are they signed?
Josh, do you have the answer?
Well, I think we are the wrong people to answer because we, like both of us, had a very hard time getting in contact with the people who are actually administering, like who are the admins of snapshot.d.o. And I guess they would be the people who could best answer that question. I don't know. And if you don't know, Philippe, then we can't answer that. Like, we are both only using that service. We are not behind the scenes doing anything there.
The next question by Sergio. Eventually, I intend to index snapshot.d.o's debug info packages in the debug.info.debian net, hopefully Debian.org by then. Do you envision any problems, limitations that may arise? I realize this is a generic question. I can provide more details if needed.
I think the main problem is the same that I had for mirroring all of those years of data, and also same Josh. You are quickly, but when we say it's quickly, it's just few minutes. If you start downloading too much files from the original snapshot services, you will just having network issues. The web server will not answer. So, like I did, I needed to use brute force methods to retry download, to resume download, because you have no choice. This is the main issue of the original snapshot services, is that it's not reliable if you do too much request at the same time, or don't trying to download too much data. So you will reach the same issue. So if you want to do so, you can check what functions I've implemented and developed to download a lot of data from the original snapshot. So you can check the project on GitHub if you want to do that.
Yeah, I can add to that. As I was writing I wrote that code that took care of all the possible error conditions and was in the end reliably downloading without errors for a period of 3 months continuously. So that code works around all the problems and works reliably. So just copy that code, and then you can download it. You have to wait a long time because you have to throttle quite a lot, but it will work and finish at some point.
Okay, thanks. And then the next question. I was recently debugging upstream HPLIP, which requires or is built on older versions of Debian, for example 10.8, while current latest was 10.10. Installing a new Debian test system would immediately update to the latest point release. Would these sites and possibly the deb change routes help stand up an older Debian system to test and debug?
Oh yeah, absolutely. You can use snapshot.d.o. You can just travel back in time and create a change route of whenever and recreate what you want. Totally possible. Of course, you don't have the security fixes, but if that's what you want, then you can do that. Yeah, sure.
I don't see any more questions at the moment. Don't see anything in IRC immediately. So, unless something pops up in the next seconds, I think you can say that we're done. Okay.
Okay.
Thank you for the presentation.
Thank you.